All right, students, today we're going to be doing an inquiry into the science of the Earth lab. So it starts out with the Earth as an apple. So an apple and a hard-boiled egg are kind of nice models of the Earth. An apple is really great because what's at the center of an apple? The part that you don't want to eat is the core. And then this skin is like the crust of the Earth. And then that delicious fruit, that delicious fruit part that we like to eat is like the mantle of the Earth. So we've got the core, the mantle, and the skin. And really, in scale-wise, the skin, the Earth's crust, is super thin. It's really, this is kind of a nice scale as far as how thin the crust is. And if this is the Earth, and we wrapped this with saran wrap, that would also be a nice scale idea of the atmosphere. We're just living in the, like 6 miles above the Earth. I mean, that's it. After that, it's space. So really cool. But the first few pages, you're going to do this little exercise, the Earth as an apple. We've got the core, we've got the mantle, we call it the convecting mantle, and then we've got the crust. You're going to cut this into smaller and smaller pieces till you see just basically what is it that we depend on for our agriculture. So go ahead and get an apple and a knife, and you can take that on and fill in those next pages. Once we get through the apple part, and then you're going to start on the rocks and minerals. Now, rocks are made up of minerals. Minerals are found naturally in the Earth. Rocks are made up of minerals. Minerals have a definite chemical composition, like calcite is calcium carbonate, CaCO3, whereas rocks are kind of like there's no definite chemical composition, and they're kind of made up of various minerals. So our first chart that we fill out involves group classification, dominant criteria, sample numbers. So I have 9 rocks here. 1, 2, 3, 4, 5. This one is so light. It's almost like air. It's got lots and lots of holes. 6, okay, 7, 8, and this almost, if I scrape with my thumb, I can scrape pieces off. And 9 looks like a bunch of shells that are kind of glued together. Let's look at them a little more closely. Number 1 has what we call foliation. There's layers of different minerals, and this forms a certain way. Number 2 has various crystals of various colors, various sizes, all kind of held together. Number 3 also has crystals within it. Number 4 is very shiny, very white. 5 is this airy, whoa, this airy rock that's very, very light. 6, this looks like any other rock that you might see. 7 has this foliation again, these layers. 8 basically looks like a bunch of sand that was kind of glued together, and 9 looks like a bunch of shells that were glued together. Now, you are going to put them, and you cannot get this part wrong. You're going to decide what are the criteria. So you're going to have group A, group B, and group C. You might say they're all like beige or yellow in color, and put 3 rocks into that group. So you would put down beige and yellow in color, and then what numbers fit that criteria. You might think some of them look like they were made of materials that were glued together. So you might say group B, materials glued together, and then put the 3 rocks you think go in that group. And one, you might say that they're mostly dark minerals, and put the 3 that you think. Whatever you decide, there's nothing you can get wrong right here. I want you to put the rocks into groups of 3. Based on some criteria, you decide. You decide what criteria. You put them into rocks, into groups of 3. Okay. So, one type of rock that we have are called igneous rocks. Igneous means fire. These are fire rocks. These are rocks that at one time were magma. They were liquid at one time, and they cooled. And depending on how long it took to cool, or if they were ejected out of the volcano, so we call it magma under the earth, we call it lava when it comes out of the earth. So depending on how it cooled, there's various criteria. This volcanic glass, which is really a favorite rock of a lot of people, this was blown out of the volcano. It cooled relatively quickly, and it just looks like black glass. Okay? Pumice, a really light rock that cooled, and lots of gases were in that magma. And when it came out of the earth and cooled, all those gases were given up. So pumice has lots and lots of holes. It's a very light, and actually a lot of people use pumice to soften their skin on their elbows and their knees. They'll actually use a pumice stone. You might know someone who does that. Anyways, igneous rocks were once liquid, and they cooled. And depending how quickly or slowly they cooled, they have various characteristics. Another type of rock is sedimentary rocks. And sedimentary rocks, as it sounds like, they were formed from sediments, from either pieces of sand, pieces of gravel, pebbles, mud, silt, plants, shells, interesting, okay? Or there's also evaporites, which you might find in a cave that were from water evaporating, and you see those kind of rocks. These are some of the names: conglomerate, sandstone. That's just sand particles glued together. Conglomerate, pebbles glued together. Okay, shale, oil shale is actually contains a lot of different oils, and so we see some various different types of rocks depending on which sediments were glued together or which sediments were evaporated off of dripping water, like in a cave or something. Okay, so that's the second kind of rock. And the third kind of rock, metamorphic rocks. And so you can see that word foliated that I used. One of those rocks was foliated, actually a couple of them. So these are some of the metamorphic rocks. Both igneous rocks and sedimentary rocks can become metamorphic rocks, can be metamorphosed by huge amounts of heat and pressure and changed into a different type of rock. For example, let's look at the granite here. Granite can be changed into gneiss. Shows it right here. Granite being metamorphosed into gneiss. Limestone being metamorphosed into marble. Sandstone to quartzite. And different types of coal being metamorphosed into other types. Something that is under lots of heat and pressure, we get a more dense result, and we often get this foliation. So what kind of rock do you think this one is? It's got the foliation. So in the extreme amount of heat and pressure that was affecting this piece, which used to be granite, which used to have crystals spread all over, because the darker crystals and the lighter crystals have different physical properties, we see them, if they're subjected to huge amounts of heat and pressure, lining up into different rows based on their physical properties. This one, I said, looked like shells that were glued together. So what kind of rock do you think this one is? Igneous, sedimentary, or metamorphic? Okay. Look at this shiny, something as dull as limestone was changed into this marble through large amounts of heat and pressure. Okay, so now what are you going to do? First of all, you classified them, and maybe you want to reclassify them now, but that's not necessary. You can't get that part wrong. Let's look now what you're going to do with our unknown rocks 1 through 8. Rocks 1 through 8. What you need to do is you need to write down the sample number. Pick out whichever ones you want, and I'm going to show you them. You're going to say whether it's igneous, sedimentary, or metamorphic. Okay. You're going to write the characteristics that made you conclude. If something looks like a bunch of sand that's glued together, you're going to call it a sedimentary rock. The characteristic, it looks like sand was glued together. And actually the name would be sandstone. So we have 8 unknowns. We have 2, 4, 6 spaces. So that means 2 of them you don't need to do. I'm going to lift up every sample and tell you a little bit. This looks just like there are pebbles that were glued together. What glues them together? This particular rock forms where there's a lot of minerals dissolved in the stream. Over time, those minerals act as glue, sticking together the various pebbles. And this eventually is what we call lithified. It goes through lithification or cementation. So, is this igneous, sedimentary, or metamorphic? And what rock is it? These are very helpful. You might want to freeze frame on one of these, or I'll put these pictures in the lab as well, okay, in the resources. So this is actually found on one of these particular sets. Oh, here's that foliated one. It's the same as this one. Okay. Igneous, sedimentary, or metamorphic. What rock is it? And the characteristics, you're going to talk about the foliation. That's really what gave it away. So this is rock number 2. Rock number 3, very light, airy. Igneous, sedimentary, or metamorphic. What's the name of this rock? I gave a clue in the introduction. Aha, this rock number 4 is very black, and it's dense to the effect that it's actually got layers, so it was pressed down quite a bit. Okay? So that's my clue on this one. The name of this rock sounds like a swear word. I'm going to just give you that. I'm not going to tell you anymore. This is that volcanic glass. This just blows out of a volcano, cools, and you get this really awesome black glass. A lot of people use it in jewelry and other things. Now, I'm going to show you that number 7 actually is a rock that when I put hydrochloric acid on it, it fizzes. Can you see it fizzing? I can hear it fizzing. See it foaming? See the bubbles? Number 7 reacts with hydrochloric acid. That is a huge hint because number 7 actually turns into this rock, which also is calcium carbonate and which also fizzes. There's bubbles. I don't know if you can see them, but there are bubbles forming. This rock changes into this rock under huge amounts of heat and pressure. I just gave away number 7. Number 8, a lot of people like this. It is foliated. A lot of people like this for their patios. And shale turns into this rock, which a lot of people use for patios or entryways. This last rock is a red rock that kind of has a lot of vesicles, a lot of holes in it. And an actual match of it is found somewhere on one of these 4 boards. Okay? Now, there's 9 samples. You only have to do 6. So pick the 6 that you know. I'm going to take off these goggles. So that's for the rocks. Very simple. Okay? Now we're going to go to the minerals. And remember, whoops, and I'm going to rinse off my hand a little bit. Here. Okay. Nothing was happening, but I just wanted to be sure. Now, here are minerals. We have unknowns from A through K. You have a helpful mineral identification chart in on your resources, so that mineral identification chart will help you. I'm going to give you data and I'm going to give you clues about each of these minerals, and from my clues you will be able to identify them. Now, minerals are going to go on this chart. The mineral code will be A, B, C, D, E, F, G, H, I, J, or K. You only have to do 5 of the minerals. I'm going to talk about each one. Pick the 5 that you're sure of when I'm done talking. Okay, you only have to do 5 of the minerals. You're going to talk about the color. The luster is kind of its shine. Is it vitreous? Is it pearly? Is it greasy looking? What does it look like? Transparency, can you see light through it? Hardness. Now, this is a scale, MOH, Mohs scale, and its hardness can be measured on a scale of 1 to 10, where 1 is extremely soft. My fingernail is about a hardness of 2, and I can take my fingernail and I can actually scrape this number 1 hardness here. 2 is still softer than a fingernail. By the time I get to 8, this is an extremely hard rock. Okay, this rock is much harder than glass, and if I rub it on the glass, I can make a line in the glass. So hardness is a scale called Mohs scale, and it's a measure of just how hard is this rock. Number 10 on Mohs scale is diamond. We don't have diamonds in our kits. I wonder why. And what's funny about diamond is just a piece of coal, a piece of graphite, a piece of carbon, which has been subjected to massive amounts of heat and pressure and changed into a diamond. In fact, there's a joke that Cameron makes on Ferris Bueller's Day Off, or Ferris Bueller makes on Ferris Bueller's Day Off, the movie, about his friend Cameron. It's kind of a funny joke. Anyway, all right. The hardness, the density, the streak. The streak is if I take this mineral and I make a line on a piece of porcelain, what color is that line? This like blackish looking rock actually makes a reddish-brown streak, which is very interesting. So streak is another thing that geologists use to figure out what mineral they're working with. Some minerals, like F, actually, they're actually, the way that their crystals are aligned, you can actually peel the layers. This mineral used to be very popular in flooring until all the new flooring came along. All right, so I'm going to go through these minerals one at a time. A is has a hardness of 3. Okay, it has a hardness of 3. That means it's harder than my fingernail. It's not quite as hard as the piece that has a hardness of 4. So if I try to make a line in this Mohs scale number 4, this is softer than 4. So I know this has a hardness of 3. Okay. Now, let's look at its density. Remember, density is equal to mass divided by volume. So I'm just going to make sure this particular piece will fit in. Yes. Okay. So I'm going to take the mass of this rock, or this mineral, sorry. Rocks are made up of minerals. This mass is 55.99 grams. 55.99 grams. Now, to find the volume of an irregular object, to find the volume of a square or something, it's length times width times height. But this, you can't do length times width times height. Okay? We use water displacement. I have 100 mils of water in here. You can see I have the meniscus, which is when water adheres to the glass, it kind of makes a little dip. And so the 100 mils is right at that dip. Now, if I add this, which weighed 55.99 mils, I can now see, or 55.99 grams, I can now see its volume. I started at 100 milliliters, and now I am at that's 120, so 12, 14, 16, 18, 118. So I displaced 18 milliliters of water. So to find the density is the mass, 55.99 grams, divided by the volume, which I said was 18. Let's see if I can say 18.0. Actually, let's make that 17.5 because it's actually like right in between the 7 and the 8. So 17.5 milliliters. Take those calculations and see what you find for the density of that. Let's look at B. B feels like soap. B is something that I can scrape with my fingernail. It's a very soft mineral. Very, very soft. In fact, it's actually the same as the one that's in this kit for a hardness of 1. It looks different. This one can look very different depending on where it formed. Okay. This has a soapy feel, hardness of 1. What is it? This one is super cool. Like I said, it has a reddish-brown streak. It's very shiny, very lustrous. Okay, reddish-brown streak. It feels pretty dense. We could find the density of this by taking a mass. We get a little bit bigger piece. The density of this, the mass is 37.42 grams. Now, I said this was at 117.5. Let's put this in here and see how much water displacement we get here. It went from 117.5 to 126. So you take 126 minus 117.5. That's going to give you the volume. take the mass divided by the volume, you can find the density of this C. D is very interesting. I can actually write with D. That's a huge hint. It's actually what we used to use for pencil lead. Maybe some pencils are still using this. What is this mineral? E, the hint with E is it's olive green. It has an olive green color. That is the big hint for E. This one, I could pull it off in sheets. I can peel. When this mineral forms in the earth, minerals are naturally occurring in the earth. And if you want to look at some crazy stuff about minerals, look at the mining going on in Madagascar by children for minerals that are needed in our iPhones. It will really blow your mind. So some of these minerals are very rare. We have a lot of minerals. We have a lot of, gypsum in Michigan. There's a big mine. We have halite in Michigan. If you go down I-75, you see that big wheel. There's a salt mine right there. We have a lot of salt. We have a lot of halite, which is a mineral. But anyways, some minerals are rare and some are very common. And some are really cool, and you can peel them. This one, we do mine here in Detroit. That big wheel on I-75, there's big piles of it right there. That's the clue I'm going to give you for G. If I put this in here to find out the density, it would actually dissolve. This dissolves in water. So we couldn't find the density of this by doing water displacement because this one dissolves in water. All right, H. H is big clue. This is a magnet. This particular mineral is magnetic. That's its really telling characteristic, that it is magnetic. Oh boy, so many people in life in the past, even today, when they find this mineral, they think they struck it rich. And they are just so excited. They think they're going to turn into millionaires, but it's a very tricky mineral. And J, let me see what's special about J. This is a hardness of 7. It's extremely hard. I can scratch the glass with it. I can do a lot. The really telling characteristic of this is its color. Look at that bright yellow. And when you burn this, it smells like rotten eggs. It is so nasty. So this mineral, the color is going to kind of give it away. So on the minerals, all you need to do is pick 5. I went through all 2, 4, 6, 8, 10, 11. You only need to do 5 to identify them, give the characteristics that led to the identification. I basically gave you clues on all of them. So this should not be too hard. All right, thanks. We'll see you next lab.